Hello aviation community and welcome to the Aircraft Certification channel. If you haven't subscribed to our channel yet, just subscribe now and click in the bell to receive a notification every time we upload a new video. I'm Rafaela Caillaux and today I have the pleasure to interview my partner Clarissa Fedel about a very relevant topic for aircraft development and certification, the so famous safety assessment. Yeah, when we talk about safety assessment, it comes to my mind all those complex fault trees with failure rates 10 to the minus 9, 10 to the minus 12. It's really overwhelming, right? Yeah, but don't panic. It is really a very complex subject. But today, Clarissa will explain it in a very simple way, starting from scratch, defining safety and building up to the safety assessment process itself and how it's related to the certification requirements. So fasten your seatbelts and enjoy your journey. Hi Clarissa.
Hi Rafaela.
Welcome for being here.
Thank you.
So today it's your turn.
Yeah, so it's much easier when I'm in the interviewer seat.
Yeah, so now the stage is yours. If you want to know more about Clarissa's professional trajectory, there is a video where she introduces herself. So we'll jump into the subject today. Okay? So you're going to start talking about safety assessment.
Right.
But I promise to the audience that you're not going to be too complicated. So now you have this easy task to make safety assessment a simple subject. Okay?
I try, promise. I try.
Okay, so can you start explaining what's safety?
Yeah, so I think that the starting point is bringing the dictionary definition about safety. So I brought here the Oxford Collocations Dictionary, and it states that safety is the state of being saved from danger or harm.
Okay.
Or a place where you were safe. So that would be a safety definition.
Okay, but then what does it mean really?
Okay, it's complicated, right? So, okay, what's being safe? So I brought here an example about traffic that everybody faces that, and to try to explain this safety concept. So if you look at these two images, you have a high traffic street in the left side and a more calm street in the right side. So which street would you feel safer to cross?
Oh, definitely the right side.
And why?
Because I feel that if I try to go across the street, it's much easier than if I try to cross the other street with lots of cars and.
So you don't feel in danger, right?
Yeah.
So you don't feel that a car would hit you in the street in the right side, but in the left side, the chance of a car hit you seems high.
Yeah,
So
it's like it's less variables to control on the right side, right?
Yes. So that's exactly what safety is. Safety is the perception. It's a perception. So if you feel comfortable, so the perception of the risk is favorable.
Okay. So
So this is what safety means. Is a subjective definition.
okay, so in on the aircraft context, in the aviation context, how would you define safety?
Who defines the safety in the aviation context is the ICAO. Okay, so in ICAO defines that the safety is the state in the risk associated with aviation activities are reduced or controlled to acceptable level. And what does it mean? Means that it's impossible to be risk-free. And what ICAO means when they mention aviation activities. That's everything related with aviation, which means operation, maintenance, and the aircraft design.
Okay, so since we cannot have like a risk-free aircraft or transportation means, who defines what's the acceptable level?
That's a good question, and that's the relation with the aircraft certification, because all the regulations are related with safety and with the acceptable risk levels.
Okay.
So in the aircraft certification regulations define what is acceptable level of risk for all the disciplines. And to understand a little bit what is this, is very important that everybody knows the concept of risk.
Okay.
And then understand what is acceptability or not of a risk level. So I would go back to that example of traffic. That's very easy to visualize. So if we see this picture, then we have this intersection, and if you try to cross a pedestrian, try to cross this street, do you think that's a high or a low risk of being hit by a car?
I would say a high risk.
And that's because we see cars crossing all directions and looks like there's no much control. But then if you go to this other picture, that you see that's exactly the same intersection, but we have some traffic lights installed, pedestrian crosswalks, and also some islands where a pedestrian could wait in the middle of the way to cross the second lane. The perception of safety is different.
Yeah, it's higher. It feels safer to cross the street than previously.
Yeah. So the risk, what is the risk in them? So the impact, the risk is the relation between the severity, the impact of what could happen, and the likelihood of this happen. So if you go back to this example, we see that in the first picture, although the impact of being hit by a car is the same, the likelihood is high because the traffic has no control. However, in the second picture, we have prevention and protection measures that reduce the likelihood of occurrence. So then you reduce the risk to acceptable levels, and a person will feel safe to cross the street. So in aviation is exactly the same thing.
Okay.
So then you use the certification requirements as reference for what would be the acceptable level.
Okay, Clarissa, so you define the safety and risk and how they're associated. So what does it has to do with the safety assessment itself?
The safety assessment is a tool, is a process that you can use to assess the safety of a system. So then you can evaluate your risks and take measures to control it. And also can be used to demonstrate that it complies with the acceptable risk levels defined by the certification rules.
So this is the so famous 1309. Is this done to show compliance with the 251309?
Yes, but not only that. So the 1309 and its equivalent 2510 in general aviation, it's related with system safety, is the general requirement for system safety, but the techniques used during the safety assessment process can be used to show compliance or totally or partially to other requirements like the 671, 901, 903, and also as input for other design criteria like the 1317 or the 1316, and even for part 33 or the part 35. So is the tool, the safety assessment tool, can be used not only for 1309, but it's much broader than that.
Okay, so there are a lot of different requirements that can be using this safety analysis.
Yes, use the inputs of this analysis as a start point or as a compliance demonstration.
Okay, so in regarding the process itself, can you explain how is done the safety assessment process?
Yeah, so as I mentioned, the system safety assessment is a systematic methodology to assess the safety of a system. So if it is used in the perfect timing in a smart way, you can use that not only to verify if a system is safe, but also to define the safety objectives for designing. And then you can design a system with a more optimized. So if you remember, Marcelo made a video about system architecture. He mentions about that you need to define properly the requirements. Okay. So this is a very important tool in the beginning of the process, so that it is useful for the definition of the requirements of a system. And how does it start? This starts with an analysis that we call function hazard analysis. When you are talking about an aircraft, we usually start with an aircraft level analysis, but this tool can be used for system level, subsystem level, so we can go down in any level. But in the beginning, if you start in the beginning of the development phase, we define all the functions of the aircraft and identify all the failure conditions and malfunctions and classify those failures and malfunctions according to the severity of the effects of its occurrence. And this evaluation is done in the level of the aircraft, the crew impact, or the passengers impact.
Okay. And what about the preliminary safety assessment?
Yeah, this is a step after the FHA. So as a deliverable of the FHA, we can define the function design assurance level and other safety objectives like probability of failures or the level of independence of systems. And the preliminary safety assessment is a way to verify if the proposed architecture has a potential to comply or not with those requirements. And as a result of this analysis, we can have additional requirements like installation requirements or segregation requirements. And when we go down in those analyses, the aircraft FHA and the aircraft preliminary safety assessment are inputs for the systems design. So then when they do the system FHA and the system preliminary safety assessment, they all need to take into consideration those requirements that came from those preliminary analyses.
Okay, so then you do this preliminary safety analysis on the aircraft level, and then you do on systems level.
Yeah, you go down, you can go down to an item level that sometimes the suppliers do to evaluate if their subsystems or the equipment are complying with this.
So you mentioned that the safety assessment is a combination of different techniques. So can you go deeper on the techniques a little bit?
Yes, I will not describe each one in detail because I think that each one deserves a video about that, but I will describe at least some of the methodologies. One I already mentioned, that's the FHA, that's the start of everything. And after, you can do a top-down analysis. The most commonly used method is the fault tree analysis, but also there's a Markov analysis and the dependence diagram analysis. All of those are top-down analysis, and the goal, so you start in the failure condition and then you are going down each layer until you find the most basic event that can contribute to that top event. Another analysis that you can do is the bottom up. The bottom up that you start in the lowest level that you know. So depending on the phase of the project, can be a subsystem, but if you are more advanced, it can be in the item level. Mm-hmm. And this is a very important tool to evaluate single failures. The most common method is the FMEA, that's failure mode and effect analysis. So you evaluate each failure mode of an item and verify the consequence. So then you can check if one single item can result in a failure condition. So then you can check the single failure.
But what about installation aspects?
Oh, that's a good point. So there's another technique used to verify the installation that we call zonal analysis. So what we do that we divide the airplane in zones and then we evaluate the installation. And that's just to verify if there's anything in the surrounding of a equipment or a system that could create a failure that is not foreseen when you're talking about failure mode. So we assess that we have any installation problem, like okay, we can have a damage in a harness because we are having a chafing somewhere, or when you evaluate one system installation in combination with some other system installation, that a failure of one system could affect the other. So then we can evaluate if you are covering all failure modes. Sometimes you need to change. We also can evaluate segregation, because sometimes we in critical systems we need redundancies. But if you don't have a physical separation, this redundancy may not exist. So then you need to evaluate this and create requirements for segregation. Also, we can evaluate accessibility for maintenance to see if the maintenance will not be induced to an error because the difficulty in access. Verify if you be needed some installation requirements to prevent that during the installation a failure will not be induced, like a foolproof tool. So it's a very important tool in the beginning to define installation requirements as well.
And how it's related to the particular risk analysis, because we had a video with Ansel talking about the PRAs, and is it part of the zonal analysis or the safety analysis? How is all that connected?
They are separate analysis, but sometimes we identify some zones that are affected by a particular risk. So a very classical one is rotor burst. So then we know that what's the zone of the airplane that will be affected by a rotor burst more directly. Okay. Because as you remember, Ansel mentions that sometimes you need to look other zones when you're talking about signals, traffic, or so on. Another thing, pressure vessel burst, tire burst. So we have zones that we needed to be more careful and analyze that. But usually the particular risk analysis is another separate, but it's identified. There's a correlation, but not necessary. The particular risk analysis that you mentioned very well is another analysis. So we need to identify all the particular risks, and some can affect multiple systems, and some affect only the systems that are inherent of this risk.
And what about when you have one system failure that could cascade down to another system failure? Like, for example, the loss of the power supply, that sometimes it can affect multiple systems. How do you deal with it?
This is also cascading effect analysis that also must be performed in the beginning, so that you can define the independence requirements for systems. So for example, we have sometimes backup systems, and then you do that everything that you think that are independent, but they are not considering a power supply, for example. Mm-hmm. And then when you have a bus failing, it's cascade and you lose both systems. So this kind of analysis is also part of the preliminary safety assessment, so that you can define independence requirements. So then you can allocate power distribution or power supply adequately, and also verify other systems that interact with others and guarantee that when one failure is not cascading, or the cascade that happens, you not be hazardous, not create a hazardous effect or catastrophic effect to the airplane.
Okay. We know that there are a lot of things on the aircraft operation and maintenance that will be subject to human errors. And how is this addressed?
There's another technique, that's the human error analysis that's done. In this you need to have a lot of collaboration of the human factor specialists and also the pilots and the maintenance personnel. So then you can assess the potential errors. So it's always you always consider that the flight crew or the maintenance crew are operating in good faith. However, they can do mistakes, tired, stressed, and all things. Of course, it has all the SMS system to help to manage all the things and mitigate the risk of those things happen, but still can happen. So in terms of aircraft design, we need to evaluate what can be done to minimize the mistakes, the errors, and if it happened, to help the recognition on time to prevent a more dangerous progression. Yeah. So for the flight crew, it's done an analysis taking into consideration if the control are adequate, if the instructions to the procedures are adequate. So in the preliminary phase is very important. So then you can define if additional monitors are required, if additional information in the cockpit is required, and also to define better how will be the shape or location of controls. And in terms of maintenance, we need to verify the accessibility, or if a placard is needed, training instructions in the manuals to guarantee that the mechanic also will not induce a problem in the airplane. So then you can put all requirements on that to guarantee that the design will be robust enough to prevent the error. Or if it happened, it will be catched by or a secondary inspection or an alert or something like that.
Yeah, so it's really a thoroughly assessment done on the design, right?
Yes.
And what do you consider are the main challenges for the certification?
In my point of view, is to reach agreement with certification authorities, because when you're doing that in the beginning, you don't know, as I mentioned, you do that in the beginning of the process, the preliminary safety assessment. And after you do the safety assessment to demonstrate compliance with the requirement. But if you only talk with the certification authority at the end, but you had a lot of assumptions at the beginning, you have the risk of the certification authority does not agree with the assumptions
that were made back there.
Yeah, so I think that is very important to have the milestones during the development of the design to discuss with certification authorities or be in constant contact with certification authorities to guarantee that principally the assumptions made during the FHA phase, because the FHA is the start of everything, that they agree. So if you see the certification requirements, they mention the levels, the acceptable levels, in a subjective way. So significant loss of margin or slightly reduction of margins. So you needed to agree with the certification authority. What does it mean in terms of the criteria that you are using to evaluate?
Okay.
So it's very important to have this contact with the certification authority to guarantee that they have the same understanding. Another thing that I would say that's a challenge, that you need a lot of integration. You talk with the designers, you talk with the system engineers, you talk with people in the structures, performance, maintainability, so you talk with everybody.
Mm-hmm. Yeah, it seems a very integrated process that you need to keep feedbacking with information through the whole design.
Yeah, so you need to have that. So you need to have this constant communication, integration, because in the beginning of the process you do everything and you define the safety objectives, and in the end of the process you do the final safety assessment to verify if is everything complying with what you define. But if you don't do anything in this between, probably some information you'll be missing. So that's why it's very important to keep in touch with who's designing the system and guarantee that all the modifications are being assessed. So I think that's the two main challenges.
Okay. And for those that are willing to work with safety, what are your recommendations?
Okay, first, don't think that you'll be a person that you'll be in your computer calculating probabilities. And I'm telling you that because there's a lot of confusion. So many people think that who does the safety assessment is the person that do the default trees and calculate probabilities, and it's not that. Safety assessment is much more a qualitative assessment than probability calculation. Of course, probability calculation is part of the work, but a small part of the work. And today we have many tools that calculate that. So if you design a proper default tree, it will be calculated by pressing a button. Who wants to work with safety assessment needs to be a person that likes to interact.
Make questions.
Yes, because you need to interact with everybody. With everybody. So I think this is the main recommendation. And not only for who will work with safety, but who interacts with a safety person, that he's not there only to calculate the probability. There's a confusion that's very common on that. And the second would be that guarantee that there's a process in the company and this process is known for everybody, because it will facilitate your work. So if everybody follow the same process when performing the FHA, because depending on the size of the company, we have like safety engineers to do that, but there's some companies that the system engineer that do that all the work. So then we need to guarantee that everybody's in the same page, everybody doing the same criteria, same methodology, to not present different things to the same certification authority person, right?
Yeah.
I think this is very important, because this facilitates the work of the authority also.
It also affects the credibility of the company, right?
Oh, for sure, because if you imagine that you are in a certification authority position and then you receive a document from the hydraulic system department and a document from the fuel system department, and they have different criteria for the same effect. So that's very important to have it very harmonized, and you facilitate the work of a safety engineer or the system engineer that work with safety.
Okay. Thank you, Clarissa. I think we covered a lot, but I'm sure we'll need future videos to go through all the techniques and stuff.
Yes, sure.
But thanks for coming. I count on you for the future videos.
Oh, you'll be here. Don't worry, you'll be here.
Yeah. I hope you liked it and enjoy your journey.